Welcome, everybody. Today we are working on Unit 10. This is kind of an interesting unit because we are going to be focusing on creating stuff instead of just utilizing stuff. So we're going to kind of review this concept of how to create a database from scratch, how to create tables from scratch, and then we're also going to look at this concept of indexing, what that means and how it's utilized. Indexing often goes along with things like primary and foreign keys. And then we also form what we call constraints, basically, that kind of limit how your tables can connect to each other and operate and stuff. And the lecture materials will flesh that all out. So at this point, our topics are listed here, and I'm going to start with the W3 schools material and go through it. Some of this is really very simplistic. The commands are very, very simple. So those, and the ones here on W3 should go pretty quick. I'm going to probably spend a little bit more time talking about the indexing and all that stuff and how it's used. And I'm not going to go super deep into all these auxiliary resources I have here, but I did provide them so that you guys can, have a reference to look stuff up. And I went and kind of found all the links and stuff and listed them all. So you can see how there's a ton of information here to draw from. And my thinking is kind of like a reference all in one place instead of like hunting around for it. All right, let's go ahead and look at the first command, which is basically just creating a database. And what I'm going to do here, once again, as I normally do, is I'm going to load this up in Brave just to suppress all my ads and stuff. All right. So it's very simple to create a database from scratch, right? So if you have a database management system like MySQL Workbench, you just very simply type in this command, create database, give it a name, put a semicolon there, press enter, or excuse me, execute the query, and you have basically the creation of a new database. Now, normally, like when you do this type of work professionally, usually all the databases are pre-created, right? Like you just sit down and you use a database that's already there. But if you do get into that position where maybe you are the database person or the database administrator, or you just want to build one for yourself just to play around, it's really not that hard to do, right? So it's a very simple command to create a database. They have examples here, right? And the only real hitch to this is you do have to be an administrator in the database. So like when you connect to the database, and like when we installed MySQL, right, the server part of it, you guys remember we set up a root password. That's like the default admin password. You basically, if you're root on a database, you can do anything you want, right? Create, destroy, or whatever. If you try this command and it doesn't work on your system, right, and it's not going to happen to any of you, but if you were on a system and you tried to do this and you're locked out, that means you don't have administrative privileges. So you have to get those privileges added to your account. Now, think about this. They're not going to give those privileges to everybody. Now, granted, creating a database, okay, it's not really destructive. You're adding something new. But the correlating command, which is drop a database, which operates at the same level, once again, you have to be an administrator. This one simple command can take a huge database and instantaneously destroy it. And I want you to be mindful of this. Once you drop a database, it's not coming back. It cannot be undeleted, right? The data is destroyed. There's some ways you can sort of like cover some of it, but in principle, you're not pulling back that data. So this command in particular is often very tightly locked down on systems. And it makes sense, right? You imagine like walking into work, and you just type a command like this and, hey, you just destroyed all of our operations because all of our data was in there, right? Yeah, they're not going to give you that privilege. But as a root on your own system, this is something that you can play with. So you can create a database and you can very, very easily drop one as well, right? The kind of interesting auxiliary command that I'm highlighting here, right? Like if you're going to drop a database, it helps to know what it's named, right? So that command that I just highlighted, which is just show databases semicolon, like if you're working in a system, like we're using MySQL Workbench, and on the left sidebar, we have a schema table, so we can see all the databases in our system. But if you're working from a command prompt and you're logged in, the only way to see what databases you have is to type this command. So this will show all the databases that are in the system, right? And then if you know the name of a database, then you can destroy it, right, or drop it. Also, if you create a new one, you don't want to name it the same as one that already exists, right? So it's not uncommon. For example, like if you have a customer database, that you might create another customer database or call it, I don't know, customer two or new customer or something like that, right? But knowing what databases you have is a very, very helpful command. All right. The next command that we're going to look at is create table. Now, this one we've kind of done sort of informally along the way. If you remember, and the reason we did it was really more about the data types of the columns that we were putting in it. So we were learning about data types, in particular. So this command is not completely brand new to us, but when you are starting from scratch, think about this, you create a new database, well, you got to create some tables to go inside of it, and you use this command. So it's just create table, you give the table a name, and then inside a set of parentheses, you define all your columns and data types. And ideally, if you're creating a table, or a database for that matter, you've already kind of sketched out a plan for what you're going to add, right? So like, you're not just going to, oh, I think I'll make a database today. You probably have thought about it and say, hey, I want to make a database for, I don't know, my record collection or for my work or for my customers or whatever. And you've thought about what tables you're going to make, how to convert stuff into normal form, right? So that's kind of like what our assignment was, like learning how to split information apart and creating the tables that you need, including joining tables and things like that. So you would define it in that fashion. The data types, of course, depend on the information you're storing. There's some general rules that we kind of follow, like, names are usually, varchar. If we're storing numeric information, it's either an integer or a double or a decimal. There's also date time types, and a few others like Booleans and characters and things of that nature, right? But most of the time we're storing text when it really comes down to it. And that's pretty important to know. Like one example I often give people is like, even like things like phone numbers that we think of as numbers really are often sometimes better stored as text. Or if you have other pieces of seemingly numeric information like a zip code, sometimes even that's better stored as text than it is as a number. There's some times that we do want to choose numbers though. So let's take a look at an example here of create table. And notice how we do create, this is a really basic, it's basically first, last name, address, and city, right? Now, first, last name, address, and city, all of those make sense to be varchar. And you notice these are set to very, very large parameters. And I would say that's excessive, like whose last name is 255 characters long. Well, there's some people out there, I guess, right? And I'm thinking, like, what was that one like Packer player like 15 years or 20 years ago, like Kabir Baja Via Mila? That was only part of his name. It was like a paragraph long. Okay, so there's some people out there, but I don't really think you need that much space with the person ID, right? And I want you to notice this is set to integer. And one thing that's real notable here is they're creating this table. I want you to notice there's no primary key defined, right? Which is really generally not a good practice. As a general rule of thumb, what I tell people is like you're designing a table. If it's not going to be one of the fields that you're going to use regularly, you can just add an ID column for the table just to make it unique and make that the primary key, even if it's a piece of information you never use, right? It just helps And you'll see as we get to indexing why that's important. This is an example of a table being created without a primary key. Generally not a good idea. Can you do it? Sure. Then it's kind of just like a spreadsheet, basically. It does not have the same capabilities as a relational database table. Can you add the primary key in the aftermath? Absolutely. You can do that with an alter table command if you wish. And that's another one that we're going to look at here in a moment. So this would go ahead and create basically an empty table that looks like this. Very, very exciting for sure. Um, then when it comes to adding information after the table is created, then you start using the insert into command. This is a command that we've also played with. And that's one of the easiest ways to put information into a database. And you can do that one entry at a time, right? Then maybe you have an application created that has a form on it, like maybe on a website, and that's grabbing the information and then feeding it into the database. So that's a possibility. Or if you have a bunch of information already, you can convert it into a series of insert into commands and build a whole database at once. And like when we started out class here, and I provided script files for you, that's basically what it was. It was a create database, create tables, and a bunch of insert into commands. And then you had a completely built out database that you just all of a sudden can utilize. All right. Another thing that you can do is do this thing called basically creating a table by using the create table command inside of another table. This is kind of weird. All right. So, and the point of this generally is, as it says in the first sentence, is to create a copy of an existing table. So look at the SQL code down below, and I think that's pretty telling. So it says create table, test table, and then we use the as command, and then afterwards we run a query on a different table. So, and I want you to think about this. We've been doing stuff like this a little bit where we grab information and then we conglomerate it or concatenate it or whatever and throw it into a column. But you can also take that kind of stuff, right? Like if I want to extract information from one of my tables and form a new table, I just run a query inside of create table command after the as keyword, and then I can take that information and it's forming a new table. Now, when that happens, the data types that you're bringing over copy into that new table, right? So if you're wondering, so if customer name is a varchar, you know, and that's a varchar, it's going to come over as a varchar. And if you have like an ID or something else as a number, it'll come over as a number, right? And so the data types are preserved from the original table. Another helpful command, especially when you're building databases, is the drop table command. This one, just like the drop database, highly destructive, not recoverable. There's no undo, folks, right? And I know we get used to that. Like if you're working in a document or a spreadsheet, you're like, oh, I didn't mean to do that, right? You can just hit the undo button or Control Z a few times or whatever, and the stuff comes back. It steps you backwards in time. When you make a change to a database, because of the nature of how a database operates, whenever you run a query that alters the structure of the database, that's permanent on the disk and the data is no longer recoverable, at least not with traditional means. Drop table example here, I mean, it's pretty darn simple, you know, drop table and then give it a name, and then that table and the data is gone and its relationships and all the other things that went with it, right? There's also a command called truncate table. This is kind of an interesting one. And it says it's used to delete the data inside of a table, but not the table itself. So think about this. This might be one that you could use kind of practically in a number of different situations. So let's say I have a database for my students, and then all my students graduate, right? Well, then I don't really need them in the database anymore. So I could go in there, just truncate my table, and it would remove all the information from the table, but I still have the structure. So now I can put my new students in there, right? So you can see how that could be pretty helpful. right? Especially if you're, reusing a database for whatever functional purpose. So truncate table is a good command just for deleting information from a table, but not the structure. Another very helpful command is the alter table command, right? This one we've also played with a little bit, by virtue of doing exercises and me guiding you through it. But this is not an uncommon thing. You build a table, you think you got all the stuff in there that you need, or maybe you put too much stuff in there, right? So maybe you're missing something, or maybe you need to remove something. You can run the alter table command. It's very simple. And typically, when we're using this, by the way, most often we're adding stuff to a table, not removing it, right? But, it is possible to drop, as you can see. So we can add a column and just simply say alter table, which table? The customer's table. We're going to add a column for email, declare its data type, and it's added to the end of the table, right? And that's pretty important. So it's added to the, whatever the last column was, well, this is the new last column. Very simple command. Conversely, if you want to drop a column, so you just want to remove it from the table, it's like, hey, we put in a column for email and we really don't need it, the command is equally as simple. You just change the word from add to drop. Of course, when you're dropping the column, I want you to notice that we don't have to declare the data type, right? And it is really 2 words, drop column. Another one that's useful is modify column. All right. And normally what we're doing is, in this situation, is changing the data type of a column. And this one's kind of tricky though, right? And to be used with caution, because I'll give you an imaginary scenario here. Let's say you have a column that stores a date time, and then you decided to change it to a varchar, but there's already data inside there. What happens to that data? And all I'm going to tell you is, like, you got to try it to see what happens. I know what happens in the spreadsheet. Like, if you guys have ever done it in the spreadsheet, it's kind of a weird thing. But in a table, it can destroy data in the process of doing it. Normally, if you're modifying the column and you're changing data types, hopefully the data type is somewhat compatible. So here's an example. If I decide that I have like a phone number field and it was set up as an integer, right? So nobody can type in dashes or parentheses. And then I decide, you know what, I'm going to switch that to a varchar. It should still be okay, and there's like maneuvers you would make to try to rescue the data and convert it first. But usually we're doing a modify column during the design process of a database, not typically in the aftermath. It does happen though. They have a couple of examples here of adding columns, changing the data types, right? And I think what they did here with the data type is they took it from a date time down to a year. So those are kind of compatible data types, so you can kind of do that. They have a drop column example, and I think the previous piece of information is really, frankly, enough to understand that concept. All right. Next thing I want to look at is constraints. So we're just kind of going right down the list here at W3 schools on the sidebar. Let's talk about what this implies, because this is kind of an important word in database design. And often when you get error messages, you'll get like weird messages that, like, constraints cannot be satisfied or something weird like that. And I don't know if you guys have ever gotten a message like that when you're coding, but it does happen. The point of a constraint, really, as it says in the first sentence, is to specify rules for data in a table, right? Now, normally, when we create a constraint, we're thinking about it in advance. So one job of a database administrator or designer is, like, when you're thinking of like what columns you're creating, is also to think about the data type, but also to think Okay, does this connect to somewhere else? And then do we need to enforce this constraint? Like, for example, like a student wouldn't be able to sign up for a class in a registration table, right? Unless they were actually a student in the student table, right? And that would be a constraint. So like a non-student can't sign up for a class, but a student can sign up for a class. That would be a type of constraint. Um, you can add constraints. Usually that my contention is best when you're creating the table because you have forethought for that. But it does happen that sometimes it dawns on you after the fact, like what the constraint should be. And you can use the alter table command to create it as well. Um, Now, I want you to notice the types of constraints that we do have available here, and then that each one of these is kind of like a separate little field of study. And I want you to notice how all of these topics here kind of flow in a stream. And this is where we're kind of spending our time here today. And even look at the subcategory on the sidebar. We're operating at kind of like the high level of a database, like the overview, the design aspect, not the nitty gritty of the data here with this stuff. All right, so once again, constraints are used to specify rules for data in a table, as it says there. They're used to limit the type of data that can go into the table, make sure it's accurate, reliable, and make sure there's no violation between the constraint and the data action. And if it is, the action is aborted, right? So if like I'll go back to the example of like students can't sign up for courses in the registration table if they're not a student, right? So the registration table would have like a little constraint saying, like basically that the student ID is a foreign key in this table and I'm going to connect them together. It says constraints can be column level, so we can have a constraint on individual columns or at the table level, right? Either one is appropriate, right? Or usable, I should say. Column level constraints apply to a column, table level constraints apply to the whole table. Okay, pretty intuitive, I suppose. All right. So we've played with some of these already. Some of these words are not new to us, right? Let's start with not null. And we'll look at the overviews first, and then we'll kind of dig into each one. But not null basically ensures that a column cannot have a null value, meaning you can't leave it empty. So when I, like, for example, create, let's say, a student file, like the ID for the student can't be empty, and I would bet like the first and last name couldn't be empty, right? That would makes a lot of sense, right? If you're entering a new student and a first and a last name is good and ID is good, right? So those cannot be null. Now, if you don't put information in, we wouldn't be able to create the entry in the table because that information is required. Another really important one is unique. And notice what this one does. It ensures that all values in a column are different. All right. Now, think about this. If you went to school, right, and you were issued a student ID, you would hope that that is unique, right? That there's not two students, earning the same grades or taking the same courses. It makes no sense, right? And sometimes we apply this unique keyword, and I want you to think about this really, really carefully, that these first two, making sure that something is not empty and making sure something unique, leads very elegantly to working with a primary key. So if you read the description on primary key, its description is it's a combination of not null and unique. And because of that, it can't be blank, basically, and it must be unique. That's why it's called a primary key. It's a combination of those two. Be mindful of the fact that the reason we have separate versions of not null and unique is, for example, let's throw it out there like this. If somebody gives you their phone number, that should be a unique thing also. Or somebody gives you an email, that should be a unique thing also. There shouldn't be another person in your system with the same phone number or the same email address. So maybe in the old days, some people would have the same phone numbers because people lived in one houses and they had one phone, but now that's not the case anymore. Everybody's got their own number now, right? So there are times when we separate those up, but otherwise what we are looking at is a primary key. A foreign key we've looked at already, so we'll kind of dig into that in just a moment here. We also have the check field that ensures values in a column satisfies a certain condition. For example, if you're getting a zip code from somebody in the United States, any one of the 50 states, their zip codes are either 5-digit or 9-digit, right? So if somebody entered in a 20-digit zip code, we could check that and say that's not valid, right? Or if they happen to be from Canada and put in their Canadian zip code with letters in it, we would stop it, right? That check would catch it. Default is one that we use to set default values for a column, right? If nothing is put in, and then we'll get into indexes as kind of our ending topic here. But let's kind of look really quickly at primary key. I think not null is pretty explanatory, and I think unique is pretty explanatory. And then remembering that primary keys feature both of those, we're kind of hitting all three topics at once with this one. Is considered good database practice, by the way, that every table, no matter how seemingly low level the table is, always has a primary key. It makes for better data integrity. And think back to your normalization exercise, right? What's first level normalization? Making sure everything's got a primary key. And then what that ultimately does is make sure that every record in the table is unique and it has at least the primary key information as part of it. Primary keys don't have to focus on one column, and this is kind of interesting. And I want you to notice the approach they're using here. Like we've done this where we say ID int not null, and then we usually say primary key on the same line, right? And notice one of the approaches that MySQL allows is for you to declare that here at the bottom, and that's kind of the only way to do a foreign key, by the way. It is possible to have what we call a composite key as well, and that's where you use more than one field at a time. Another approach, right, and given the fact that a primary key is technically a constraint, right? So it's like we can't have that entry in the table unless we have a primary key. You can also use the constraint keyword along with this. And I want you to notice in this one, we're using multiple columns. And what we're doing is we're forming a constraint and we're giving it a name called PK person, primary key person, and it combines the ID with the last name to ensure that it's unique, right? My thinking is, real frankly, that the ID should be enough to do that on its own. But this is a technique that was not uncommon to use in the past. And in fact, I've built databases where I did exactly this, had an ID in combination with the last name. So that forms what we call a constraint. So in other words, if I have an ID in there and I don't have a last name, it's not going to let me put the entry in. I'm going to have both pieces of information at a minimum. And those two columns together act as the primary key. So if you did like the example from before where you built the table and you didn't declare a primary key, guess what? You can add it afterwards using this very simple syntax. Or if you wish to combine multiple columns, you can add it as a constraint as shown in the lower example here. So that's totally doable. So sometimes people, if they're kind of brute force building a table, yeah, we need name, address, phone number, blah, 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 right? You can do that. And then later on, you can say, okay, what's our primary key? All right, let's just put it on the ID, right? So that's doable in the aftermath using the alter table command. Since you can add it in the aftermath, you can also drop it in the aftermath. So if you want to drop your primary key, you just say drop. And I don't know why you would do this, but maybe there's a circumstance where, I don't know, maybe it was a last name, first name combo that was a primary key. And you want to remove that and then add an ID field that becomes a primary key. So there would be a reason why you would drop it. Let's talk about foreign keys a little bit. Um, and remember, the foreign key really is a way to ensure the connection between tables are valid. That's a really, I think, a good way to put it. So typically a foreign key is a field, or it says here a collection of fields because you can use combinations that refers to the primary key in a different table. So whether that primary key is a single column or a combination of columns or a constraint, in other words, that can be pulled into a different table as a foreign key. And I'll go back to the example of like a student wanting to register for a class, and in the registration table, they can't register unless their student ID is a valid primary key in the other table, right? So that is very, very common. Um, and I want you to look at some of the syntax here too, which I think is important. A table with a foreign key is called the quote unquote child table, right? The table with the primary key is called the reference or parent table. So in other words, once again, like if, here's an example, right? In the orders table, you can't get an order in unless you're a customer in the persons table, right? So in order for this column to work correctly in this child, key or table, it's got to be a primary key up here. Right? Really, the foreign keys are the way that we form relationships in tables. It really kind of makes the whole relational database thing valid. You know, um, and I think we have a nice little description here. It says, notice the person ID column in the orders table points to the person ID column in the persons table. Yes. And then the person ID column is the primary key in the persons table, but the person ID column in the orders table is the foreign key, and therefore the connection and the foreign key constraint, right? So a foreign key really is a constraint. We're being constrained to adding people to this orders table by virtue of the fact that they exist in the person table above, right? So the constraint prevents invalid data from being inserted into the foreign key column because it has to be one of the values in the parent table. And I think most of you get that at this point. In order to declare a foreign key, and we've done a little bit of this already, foreign keys need to be declared in this fashion where you basically put it at the bottom. The convention is of your column listing as you're building your table. You say foreign key, you indicate the column which is affected and what it references. Where, in other words, where is it coming from, which table and which column. And usually, in the parent table, if it's named a certain way, really strong recommendation, name it the same way. I have seen people do that and then they get really confused where they change it and they're not the same. Then they have to go, back and try to figure it out. But it makes a whole lot of sense to just name them the same thing. So if you're wondering why you have a table and you don't just call the ID column ID, the reason is so that when it becomes a foreign key somewhere else, it's very clear where it's coming from. It says to allow the naming of a foreign key constraint for defining a foreign key on multiple columns, use the following syntax. So I want you to notice here that they're doing a combination, right? So they're taking, all right, so they have their primary key here, then they're setting up a constraint. Notice when they're setting up a constraint like this, where they're going to use a couple of columns, right? They're using FK as a prefix, right? It's not required, but it's kind of a convention database people use. And what they're doing is they're taking the person ID and then they're saying that it references that. So this is just an alternate way to use the syntax on multiple columns, right? So, and this is an approach. Now, most of the time, I don't really think the multiple column thing is necessary, but you do run into legacy databases where they do that. And when they're doing it, they do it for very specific reasons. Usually the databases tend to be really, really large, is when that happens. You can also use the alter table command to assign a foreign key. So with the same syntax you would use in creating it in the first place. You can use an alter table command. And this is not an unusual thing to do. So like you build some tables and then you go in the aftermath. Oh, we're adding a new table. Oh yeah, we should probably make this a foreign key and then link them together, right? So this is a thing that you do. You can drop them as well, and that's pretty normal. All right, let's talk about the check constraint. And this is basically, notice first sentence, it says, used to limit the value range that can be placed in a column, right? And very, very often, this is a numeric thing, right? Not that it can't be used with other things, but it's generally a numeric thing. And it says, if you define a check constraint, it will only allow certain values for this column, right? If you define a check constraint on a table, it can limit the values in certain columns based on other values in other columns in the row, right? So, and that gets a little bit more complicated. But let's just look at this like basic example here. Like you're making a table of persons, and maybe this is a voter table, right? So what's the constraint on voters? Well, you have to be greater than or equal to 18 to vote, right? So that would kind of make sense. And so you define the column as you normally would, but then any value that goes in there, you're going to run a check and make sure that it's 18 or over. If it's 17, it's going to kick it back and not let you add that record to the table. You can use the check constraint on multiple things. And in fact, you can do combos. So then this is this example here, where we're checking to see if the person is 18 or over and they're in the city. So maybe the city is having a vote for mayor or something, right? They're not going to let somebody from a different city vote in their election, right? So they have to be from the city and 18 or over. And that's a combination constraint. So it's like we're checking two things at the same time. Not unusual, by the way, right? Think about it like this. Maybe if it's like a voter thing, you know, it's I think a good example for the 18 plus. And maybe you have a column that's a true false for US citizen, right? So if you're a citizen, you can vote, and you're over 18, you can vote, right? That type of thing. All right. You can use the check command, of course, with alter table, as you might guess, and to do a combination constraint as well. You can also drop those constraints also. I think it's kind of interesting, and when we get into MySQL Workbench, we're going to start to see, like, when we look in our schema table, some of the little branchy stuff that comes off of our little triangles as we expand our database structure. And you're going to start to see things for like views and indexes and et cetera. And you're going to understand why they exist now, where in the past you're probably, what is this all about, right? And so we're starting to fill in some of those blanks. Sometimes when you build a database, you do want to create a default value for a column, right? And, you know, I'm drawing a blank on an example right now, but I'm sure they're going to have one below. But maybe you have a default value that you want to set for something if somebody doesn't specify, you know, an entry. So here, for example, maybe they're creating a table of persons. Maybe this is a vote. Let's go back to the voter registration thing. Maybe this is a table of persons who are registered to vote in a different city. So if they're signing up for this database, I think it's pretty safe to say that the default for city should be the city that they're in, right? So you don't need to enter it. Of course, if they do enter it and it's a different city, then maybe we disallow them to vote, right? And then you would have probably a check constraint in there as well. The default constraint, and this is kind of a good usage, I think. So for example, if you have an order table, you can set up a default that it grabs the current date. And this is a current date function, which you can run right inside here. And guess what that does? It reaches into your computer system, pulls the current date and time, and timestamps it right into the record when the customer placed the order. So then when you're looking back later and you go, when did the customer place the order? Oh, it was at 11:30 a.m. on November 10th, 2025. That's when they placed the order. Now you know exactly when it happened. And that's a real common use for default, by the way, is to timestamp entries. And there are a lot of database administrators when they're building database tables, they put in a field like this, like a record date. You're like, when was this record created? Not that they would ever use it again, but if they're curious, they can see. Some of them also add fields for like who the user was in the database that created the record, right? Just to track things. Makes a whole lot of sense if you think about it. You can set defaults in the aftermath using alter table. You can also remove defaults in the aftermath using a drop command, right? And if you don't remember the syntax on like alter table and adding stuff in the aftermath, this is what W3 Schools is for. You just come here, look it up, and you're ready to roll. All right. Next thing we're going to look at is create index. And I think we'll probably also look at auto increment because those two do go together quite often. All right. The first thing I'm going to say about an index, right? And I like to use this analogy. When we used to go to the library in the old days, and I don't know, like some libraries might still be like this. Maybe you guys even remember libraries like this. Before they had computer systems that ran the card catalog, did you guys ever go to a library and you go to, and they had little drawers with index cards in them? You guys remember that, right? Totally old school. And think about what those were. You'd walk up to the card catalog, that's what they called it, and they would have one collection of cards that was the title of the book, another collection of cards that was the author, and another collection of cards that was the subject. Now think about this. They all index every book in the library using a different criteria. One just said, well, what's the title? We'll look up the title. One's like, who wrote it? And the other one is, what's the topic about? Car repair, fiction, whatever the topic is. And so what they essentially did in the library is they had 3 different indexes to be able to locate the book depending on what you knew about the books. If you knew what topic you wanted to look up, you'd go look up, I don't know, like fishing, right? And then you find all the books about fishing, and then you find that section, and then you go look at the books and find the one you want. Or if you know who wrote the book, you find the author, and then you get the Dewey Decimal Number and go find it on the shelf, etc. Right? But there were 3 different indexes on the same grouping of information. I think that's really fascinating when you stop to think about it that way. So I think that's a really good example of what an index is. To create an index, we just use this simple command. So this can be done on a table that already exists, right? And notice like the purpose of an index is to use to retrieve data from a database more quickly than otherwise. Because think about this. If you were at the library and you want to find that book on fishing and you didn't know how the books were organized, what would you do? Very seriously. You just walk up and down the aisles, you go, okay, this looks like a horror book. This looks like a science book. This looks like a magazine, right? And you would just keep looking. It would take you forever to find it. And the whole point of the index is to be able to find it more quickly because it tells you where to go look, what aisle, what shelf, and what the number is that you're looking for because they're ordered, right? So that's the whole point of an index. It says the users cannot see the indexes. They are just used to speed up searches and queries. And I want you to think about this. When you pop up on Google and you search something, right? Is it just now going out to the internet to look this stuff up? How does it that it comes up with the responses so quickly? Because Google indexes its searches on the internet. So they have like software that runs over the internet, visits every web page, scrapes the content, stores it in a database, and then they index the database so that when you go to look up that term, it's right there. And it's super fast. And you're like, wow, that was amazing that I found it so quickly. And that's how, the concept really worked. So when you have databases that are really, really large with lots of information, indexing the information speeds up retrieval of data. Simple as that, right? It says updating a table with indexes takes more time than updating a table without, because the indexes also need an update. So if you add a bunch of information to a table, you have to re-index it. It's like getting new books for the library. You got to add those cards to the card catalog. It doesn't happen automatically. You have to run the index command again. So it says only create indexes on columns that will be frequently searched against. So for example, if you are looking up your student records, chances are your ID number is indexed, right? Or your name is indexed. They're probably not going to index your street address. See how that makes sense? So to create an index, it's pretty simple. We basically use one of two formats, right? So we create an index, just a generic one, which is the top example. We give the index a name, right? And there's a naming convention for it. You indicate which table it is and which columns are being indexed. If it was the library, it would be the title, the author, and the subject, right? There's an example. It wouldn't be all the words in the book. That makes no sense. But the title, author, and subject does make sense. You can also make an index unique. So basically, duplicates are not allowed. So I couldn't have, like, for example, the library might have 5 copies of Moby Dick. You know what I mean? And they wouldn't have, if I used unique, they couldn't do that. They couldn't point to the same title, basically. When you create it, here's an example, and I want you to notice the prefix that they use for naming an index. This is a convention, mind you, not a rule. You don't have to say IDX underscore in front of it, but a lot of programmers do that. Some of them just use ID, or some of them use IX, or some people spell out the whole word and say index last name. But the whole point is we put the prefix in front of it, so when I'm looking at this in code, or looking at it at the sidebar in my schema table, I can immediately go, oh yeah, it's an index, right? Right. So if I create an index, I just issue this command and I run it on the person's table for the last name column. That's a really common thing to index, is last name, right? I don't know their ID number, but their last name is, Jones or whatever, right? If you add a bunch of new people to the database, then you create a new index, right? And yes, you can drop the old one and create a new one, and then you have all the new information in there. You can do it on multiple columns, so you can do combinations. So maybe you would do last name, first name. You can create an index on that if you wish, so you can do multiple columns. You want to get rid of an index, right? You just use the drop command with an alter table, and then you would probably be recreating it because you have new data. Right. Last topic here we're going to hit on is auto increment. And this is kind of an interesting one, and I think it's kind of self-explanatory, but it basically allows you to create automatically a number that increments without being touched. So for example, if you were tracking your customers, like every time you got a new customer and you added them to your customers table, you could have their ID number, or maybe just a count, I don't know, that just every time you add a new record, it's not information you're entering, it automatically just counts up, basically. So here's an example. Like if you're doing an ID on a table, and this one we're doing person ID, and you can see that's the primary key. They don't want it to be null, and we add an auto increment. So the first person gets ID number 1. Second person you enter, that's ID number 2. And the thing that's really important about that is when you're creating the record, you don't have to do anything. Like if you're inserting data into it, you don't have to do anything about the primary key. It will automatically assign itself. I know here at Gateway, when they issue student IDs, it's not exactly an auto increment. They have some sort of random thing on it, but it's sort of an auto increment, right? If you look at people that have been at Gateway, either working or students a long time, their ID numbers will start with zeros, Like, and then if you look at people who sign up today, I don't know what your ID numbers start with now, like a 1 or a 3 or something. I don't even know, right? But you can always identify gateway people that have been here forever by their ID numbers, like starting with zeros. And it's pretty humorous, actually, when you look back at it. So that's a really common one, I think, especially for doing things like IDs. And if you don't want the ID, for example, to start at the number 1, you can do an alter table command here, right? And you see that we are going to start at a different value. So maybe you want to have a 4-digit ID or a 6-digit ID. You can declare what the first starting number is. So if I wanted a 6-digit ID, I would set that to, 1 with, 5 zeros after it, or whatever number I want to start with. That's totally allowable. When you add a new record, right? So here you're just adding first name and last name, and then you look at the table afterwards, you would have an auto incremented ID automatically added to that record that you didn't have to mess with. So I think that's actually a very useful feature, by the way, when you're creating database content, is not to have to worry about creating a new ID and then trying to make sure it was unique and all that kind of stuff. All right, folks, that covers all the lecture materials. I do want to point out once again that that covers it from the W3 schools perspective. And then what I've done here is giving you alternate information from the MySQL tutorial site, where they go through a lot of this stuff. By the way, talking about a lot of the same commands with a slightly different perspective, so you guys might find this useful. The constraints that we use are kind of detailed here. We did talk about those in the lecture material. They should look familiar at this point. And then a couple of other things here about index types, and then being able to work with more advanced index features. And we're not really digging in that deep, but I do want to make the information available to you. So if you guys want to look that up, and you're thinking about, let's say, indexing some information, what that might look like and what ramifications it might have, this is a helpful little guide here at the bottom to maybe help you solve the situation. All right, that covers all of our lecture topics. The only thing left are these use index hints, right? And all I'm going to say about this is pretty self-explanatory if you read it, but let's call this the lecture, and this video will stop here, and then we'll come back and we'll do some coding and create a database and build something. All right, this video is over and done.